On Friday, parts of Germany hit 41 degrees Celsius, a new national heat record, part of the country's fourth heat wave of the summer building under a stubborn dome of high pressure that had been locked over Central Europe for nearly 2 weeks. Switzerland tied its own highest reliably measured temperature ever recorded that same stretch, at 39.7 degrees. By Saturday, that same ridge of high pressure finally gave way. And what replaced it was not gentle relief. A violent sequence of severe thunderstorms tore through southern and eastern Germany, dropping massive hail that paralyzed transit hubs, fractured infrastructure, and sent emergency crews scrambling across multiple states at once. This is the story of exactly how a record-breaking heat wave collapsed into one of the more dramatic, severe weather outbreaks Germany has experienced this year, why that specific sequence, extreme heat followed almost immediately by violent hail, is not a coincidence, but a well-understood meteorological mechanism, and what it tells us about a pattern that has now repeated itself across Germany multiple times this summer alone. No exaggeration, just what the German Weather Service, insurance industry loss data, and the meteorologists tracking this exact event are actually reporting. Drop a comment and tell me if you were anywhere in southern or eastern Germany when this hit, because the shift from record heat to hail chaos happened in less than 24 hours, and I want to know how that transition actually felt on the ground. I read every one of these. If you want grounded weather coverage instead of recycled panic, subscribe. It is free, and A-Like helps this reach people across Central Europe before the next one of these hits. Let us go for 5,000 likes on this one. Now let us get into it. To understand why Germany's heat collapsed into hail this violently rather than simply cooling off quietly, you first need to understand what a heat dome actually is and what it takes to break one. The pattern, responsible for this fourth heat wave, has been described by meteorologists as a textbook omega block, a ridge of high pressure flanked by two dips in the jet stream that together trace the shape of the Greek letter omega across an upper-level weather map. That ridge acted like a lid for nearly 2 weeks, trapping hot, increasingly humid air directly over Germany and the wider region while blocking the normal parade of Atlantic weather systems from passing through. The longer that lid stays in place, the more energy builds up underneath it, since the ground keeps absorbing heat day after day, and the air keeps growing more humid as moisture evaporates upward with nowhere to escape. When a ridge like that finally does break down, it rarely does so gently. The same instability that had been suppressed. For 2 weeks gets released essentially all at once, and the specific combination of a rapidly destabilizing atmosphere, extreme low-level heat and humidity, and strong wind shear aloft is precisely the recipe that produces the most violent form of thunderstorm, the kind capable of generating very large hail rather than an ordinary summer shower. Large hail forms specifically inside powerful, rotating updrafts called supercells, where hailstones get carried repeatedly up and down through the storm's core before finally falling once they grow too heavy for the updraft to support any longer. A storm fed by air that has spent 2 weeks baking under an omega block carries considerably more of the raw ingredients, heat and moisture, that power those updrafts than an ordinary storm would, which is part of why the hail produced. Once a heat dome like this one finally collapses, tends to run larger and more damaging than hail from a typical summer thunderstorm. German meteorologists have been explicit that the mechanism driving this pattern is not unique to this particular event. It is the same basic collapse sequence that has played out repeatedly across the country this summer, including a mid-July outbreak that dropped hailstones reportedly the size of tennis balls in Heidenau, south of Hamburg, smashing car windows and damaging roofs, and forcing officials in Bavaria to bring in snowplows to clear roads that had been turned white by accumulated hail during a separate storm episode earlier in the season, with police in the town of Kempten alone fielding roughly 700 emergency calls in a single overnight period during that earlier event. The scale of Saturday's collapse was serious enough to draw national attention well beyond typical severe weather coverage. Reports described a devastating sequence of severe thunderstorms, torrential rain, and massive hail battering southern and eastern Germany, fracturing infrastructure and paralyzing transit hubs across the affected region, arriving immediately on the heels of the record-breaking heat that had gripped the country just days earlier. That kind of rapid back-to-back transition from a genuinely historic heat record to a transit-paralyzing severe weather outbreak within roughly 24 hours is precisely the pattern meteorologists mean when they describe a heat dome's collapse as violent rather than gradual. It is worth putting this event in the context of just how costly hail specifically has become for Germany, because this is not a marginal weather hazard in the country's overall disaster picture. Hail is responsible for roughly 40% of all insured losses from natural catastrophes across Germany, putting it on par with the damage produced by winter storms. A genuinely striking figure given how localized any individual hailstorm actually is, since the thunderstorms that produce damaging hail typically span only a few. kilometers in diameter. The costliest hailstorm in German history struck Munich on July 12, 1984, causing roughly 1.5 billion Deutschmarks in insured losses. And the Reutlingen hailstorm of July 2013 caused more than 600 million euros in damage to residential buildings alone across a single, densely populated stretch of Baden-Württemberg. While a separate outbreak centered on Bad Bayersoin and Benediktbeuern in Bavaria in August 2023 produced hailstones measured up to 10 centimeters across, contributing to roughly 900 million euros in storm-related losses that month alone. Those historical benchmarks matter for understanding Saturday's storm, since German insurers have consistently found that a small number of severe, loss-intensive hail events account for a disproportionate share of the country's total weather-related insurance payouts each year, meaning a single violent outbreak like this one can meaningfully move the needle on the country's entire annual disaster loss total. It is worth being precise here about what can and cannot be said with full confidence about this specific event so soon after it happened. Comprehensive figures on hailstone size, total damage cost, and injury counts from Saturday's outbreak specifically were still being compiled by German authorities and insurers in the immediate aftermath. And researchers who study hail in Germany have been explicit that the country still lacks a fully standardized, long-term measurement network for hail specifically, unlike some other European countries that operate dedicated hailpad networks capable of tracking trends with more precision. That measurement gap means individual events like Saturday's storm tend to get assessed, initially through a combination of eyewitness reports, insurance claims, and radar-based tracking algorithms, a process that can take days or weeks to fully resolve into a confident final damage total, even though the immediate transit disruption and infrastructure damage were clear and significant from the very first hours of the event. There's a broader pattern connecting this event to the rest of Germany's summer that is worth understanding, because Saturday's collapse was not an isolated occurrence. This has been Europe's fourth distinct heatwave of 2026, part of what meteorologists have described as a summer of stifling, nearly back-to-back heat events, with barely a breather in. Between and each of those heat domes has been driven by the same recurring omega block mechanism settling repeatedly over the continent. Germany specifically has now experienced multiple rounds of this exact heat-to-hail collapse sequence within a matter of weeks, from the mid-July tennis ball hail in Heidenau to the Bavarian storms that required snowplows to clear accumulated ice from summer roads, to this most recent nationally significant outbreak following Friday's record 41-degree heat. That repetition matters for understanding this not as a single freak event, but as a recurring feature of how this particular summer's atmospheric pattern has been behaving across Central Europe. So what does all of this actually mean if you live anywhere across Germany or the wider Central European region right now? The practical lesson is that a heat wave, this intense breaking, should not be read as a simple return to calm, ordinary weather, since the same stored energy that built up during 2 weeks of record heat has to go somewhere once the ridge holding it in place finally breaks down. If severe weather warnings are issued for your area following an extended heat wave, treat them with real seriousness. Move vehicles under cover if hail is specifically mentioned in a warning. Secure loose outdoor furniture and cover skylights or greenhouse glass where possible, and avoid unnecessary travel during the height of a storm given how quickly transit infrastructure was disrupted during Saturday's outbreak specifically. More broadly, given how many times this exact heat-to-hail sequence has already repeated across Germany this summer, treating any extended stretch of extreme heat as a setup for potentially severe weather on the back end, rather than an isolated event with a clean, gentle ending, is the more realistic way to think about the pattern this particular summer has established. The honest, grounded summary is this. Germany's fourth heat wave of 2026 peaked Friday with a new national heat record near 41 degrees Celsius, part of a broader omega block pattern that has repeatedly dominated Europe's weather this summer and pushed Switzerland to tie its own highest reliably measured temperature on record in the same stretch. That ridge collapsed within roughly a day, unleashing a violent sequence of severe thunderstorms and massive hail across southern and eastern Germany that fractured infrastructure and paralyzed transit hubs, the same basic heat-to-hail collapse mechanism that has already played out multiple times across the country this summer, including tennis ball-sized hail in Heidenau in mid-July, and hail deep enough to require snowplows in parts of Bavaria. Hail specifically accounts for roughly 40% of Germany's total insured natural catastrophe losses in an average year, on par with the country's winter storm losses, meaning a single severe outbreak of this scale carries genuine financial consequences well beyond the immediate disruption, even as full damage figures from this specific event continue to be compiled in the days ahead by insurers and national meteorological authorities. We are going to keep tracking this pattern the way we tracked it today, straight from the German Weather Service, national insurance industry loss data, and the meteorologists studying this exact heat-to-hail collapse mechanism, not recycled headlines. Subscribe so you do not miss it as final damage figures from this storm get released, or if this same Omega Block pattern rebuilds again later in August, because based on how many times this sequence has already repeated this summer, another round remains a real possibility. And leave that comment below. Tell me if this summer's back-to-back heat waves and violent storm collapses feel different to you than previous years, because that lived experience is exactly the pattern. Meteorologists studying this Omega Block have been trying to explain with hard data all season, because behind every one of these damage reports is a commuter in Munich or Nuremberg whose train home was suddenly stopped cold by hail piling up on the tracks, an insurance adjuster already bracing for a fresh wave of claims on top of a summer that has already produced several, and a farmer somewhere across Bavaria watching a crop that survived 2 weeks of record heat get shredded within minutes by the very storm that finally broke it. A loss that will not show up in any national damage total for weeks, but is already fully real to the family standing in that field today. 5,000 likes on this one. Let us go. See you in the next one.